Wait, is it recording? Yes, it is. All right, so 11B and C, you're doing what we call indefinite integrals. And here's a couple of notes to fill in. So differentiation finds the gradient function for a function. So when you derive, you're finding the gradient function. But when you antiderive, that essentially finds the function from the gradient function. If that was confusing, essentially it's going backwards. Okay, so how I show it in this notation. The first notation here, I'm saying if this is your function, f of x, and I decide to do derivative, so delta f delta x, that means find the derivative of f of x, we then say f dash of x. Okay? But then when you say antiderive, so you see what I'm doing here is I'm saying, what if I antiderived the derivative? Then whatever you do to the right, you do to the left as well. So antideriving the left, antiderivative of the derivative are opposites of one another. This is why when we say antiderive the derivative, it equals to f of x. That bit. Okay, so we're just saying when you antiderive a derivative, so going the opposite direction of a derivative function, you're essentially getting your function. Okay. A couple of details when you're doing this. So students can write antiderivative of the derivative. What are you missing? That dx. If you miss out on this dx, they will penalize you. Okay, that's the reason why is remember how I taught you about estimation of areas? Area under the curve relies on the fact that you're making these rectangles, and these rectangles had the height, which is the function, but also the change in x. So this here means sum of all the areas, and then dx is timesing. So one is called the length times the width. So if you don't have dx, which is the width of the rectangles, it doesn't make sense. Can't be the area. That's why if notation-wise, if you don't have the dx, they will penalize you each time and every time. Okay? All right, so that's the notation bit, making sure to have the dx. When you find the antiderivative, it's also known as the indefinite integral. Indefinite integral meaning that you're not finding the area yet. You're just finding the function for it. So it's like an area function. Okay? In the next exercise, that's when we start doing definite integrals. Okay, so the next one we do. But right now it's called indefinite. Means you don't have intervals. You don't have an A to B. Here we go. These are your 4 key rules. And to derive a constant becomes A of x plus C. But out of them all, the ones that I think students should know from last year, you should already know this one, 2A. And to derive a x to the power of n was actually just the reverse of a power rule. So if you remember the power rule, if I gave you f of x equals to x to the power of 3, the derivative, you told me using power rule, drop down the 3. So the power is 3 times x to the power of 3 minus 1, right? So the antiderivative is the opposite of everything you just saw there. Antiderivative is going backwards. So instead of minus 1, I add 1 to the power. See how there's a plus 1? So the plus 1 is adding 1 to the power back again because you minused it. Now I'm adding 1. Instead of timesing, it's dividing. That's why it's dividing by n plus 1. Okay, so it's pretty much just the reverse of the derivative rule. So if I wanted to go back from this step, so the answer here is 3x squared. If I want to go from 3x squared back to the function, so if I antiderive 3x squared, don't forget the dx, then according to the rule, I need to add the power by 1. So it'll be x to the power of 2 plus 1, so it makes it back to the 3 that I want. But remember, you had this 3 at the front. So instead of, you got it because you times, then now the reverse is divide. That's why I have to divide by 2 plus 1, and that's what the rule's saying. See that? N plus 1 and divided by n plus 1. That 2 plus 1 will cancel out the 3. And that's how you end up with x cubed. Okay, so essentially, this question, or this rule here, is the reverse of power rule. That's all it is. Okay, so it looks scary because it has the fractions and all that, but it literally is just going backwards of what you would have normally done for the derivative. One thing to note, see this plus c? Last year, did your teachers explain why there's a plus c there? Someone tell me. Because we got the x cubed. Seems like I've got my answer already. Why do I have to put a plus c in my answer? What was the explanation? Anyone remember? Charles. Beautiful. There's a lot of ways you can visualize what Charlie was just explaining just now, but I think that final bit of what he said makes a lot more sense for those who are just looking at my example. You see, if I gave you f of x equals x cubed plus 1, so vertical translation like he's saying, if I asked you to find the derivative, it's still 3x squared, because the derivative of a constant is always going to end up being 0. But that means if I find the antiderivative of 3x squared, what I don't know is, was it actually x cubed? Or is it x cubed plus 1? Or is it minus 1? There's infinitely many possible answers for vertical translation that I haven't accounted for. Okay, so that's why you have to put a plus c. Now, at the very end, I did put a note here, which in the exams you have to be careful. There's a difference in the wording. If they ask you to find an antiderivative versus the antiderivative. An antiderivative, if you see that in the exam question, it means that you have to give me one antiderivative equation. So C could be any number. Traditionally, it could be 0 because that's one version of it. So when you see an, often the answer will then be just x cubed. No plus c, plus 0. But if they say find the antiderivative, it means that there's multiple possible answers. Then the plus c accommodates for that. The plus c means that there's many other possibilities that I don't know. So if you did an antiderivative, you have to pick something for c. Often it is a 0. So that's what I wrote in my notes here. Often it is 0. But if they say find the antiderivative, then you must put in the plus c to accommodate for the family of curves. Okay? So I just highlighted this is what you did last year for year 11 that you might need to practice. Year 11 then moves into this bit here for year 12. If you didn't see this last year, these two are pretty much the same. One's just the chain rule version of it, so the reverse of it. And it's the same idea again. It's add the power by 1 and then divide it by that new power, except because there's an a, a coefficient, that's why we also have to divide the a as well. So the only difference between 2a and 2b is that whether in front of n plus 1 has the a or it doesn't. Okay. We'll do some examples of that soon. What makes this tricky in this exercise is that 2b and 4b look very similar. You see, ax plus b to the power of n, it says as long as n, the power is not -1, I could have had antiderive 1 on ax plus, actually I shouldn't use ax, let's do 3x minus 1 all to the power of 2. See that? Versus antiderivative 1 over 3x minus 1. So this one belongs to 2b. This is a 2b example because I can write that as antiderive of 3x minus 1 to the power of -2 delta x versus, why is this a 4b? So this is a 2b example. This is a 4b example because that means this has a power of -1. So notice there, it has to be a power of -1. Okay, so this one says not -1, this one says definite -1. Two of them are different. So one gives you a power function, one gives you a log. Okay, so that's the main difference. And if you look at the past exams, in exam 1, they will flip between these two examples almost alternating each year. And only recently that I've seen that they've changed that. because previously that was one that students get confused between. So I often say, learn this first. Okay, so learn the difference between 2b and 4b. 2b is one where you have any power except -1. 4b is when it literally is just 1 over ax plus b. Okay? Now, one little caveat. Let's look at the rule for 4b. 4b, when you antiderive a1 on ax plus b, the 1 on a makes sense. Just like all the other ones, there's always a 1 on a at the front because if we did the chain rule, the a will come to the front, so you have to divide it. So that makes sense. But why is it that you have log e of, and now you have an ax plus b or negative ax minus b? Now for special students, that would make sense. For a lot of the method students, this is going to be your first time learning absolute functions. Okay? Technically, in your textbook, sometimes they write this in one go. I'm just going to get a show of hands if you've seen this before. Have you seen this rule before? So antiderive 1 on ax plus b dx is equal to 1 on a log e and then this vertical line. I'm just going to rub this out. Can I get a show of hands who've seen this bit, especially the just the method students only? Hands up if you've seen it. Okay, so 1. All right, cool. This bit is what that description is trying to say. So I'm going to try to describe what it means, okay? What they're trying to say here is that there's two scenarios that when you antiderive this function, there's two possible answers. Why? Let's show you why so that you can have a better understanding. If you did the derivative, it's always the derivative because when we do antiderivative, it's going backwards. But if you notice this, if I gave you f of x is equal to log e of, let's go, 2x plus 1. Okay, so let's do our chain rule again. Let's practice chapter 9 stuff. Derivative. See what you remember. Derive the inside and then derive the outside. Yeah? What's the derivative of the inside? Can I please have, let's go with Krish. What's the derivative of the inside? 2. So derive the inside, I get 2. Then you got to derive the outside. So here we go, I'm going to derive the outside. So log of something. What's the derivative of log again? Very good. So it's 1 over, and whatever's inside, so it's 2x plus 1, right? So together, we had 2 over 2x plus 1. So far, so good. But what if I changed that now and I did f of x log e of, and I did the negative of the inside. So instead of 2x plus 1, the negative of that. That's what it looks like. So I put a negative in front of it. 2x plus 1. So I still keep the 2x plus 1, but I put a negative in front. So if you expand the brackets, I'm asking you, what is the derivative for log e of negative 2x minus 1? Now let's see. What's the derivative equal to? Can I please have, I'm just going to delete this bit. Ooh. Oh, that's not cool. Let me do it again. There we go. Same thing again. Let's do it. Derivative of the inside. What does this give me? -2. This gives me the -2. And then now if I said, find the derivative of the outside, that should be the same thing again. It should be 1 over whatever you currently see. But here, hopefully you start to see something a bit odd here. When I put it together, I get -2 over -2 minus 1. But notice there's 2 negatives on the bottom. If I take the negative as a common factor out, you end up with -2 over 2x plus 1. True? Because if I take out the negative, -2x, and that's minus 1, the double negatives up here cancel out. But if they cancel out, this answer that I've got here is exactly the same answer as what you got up here. Why is that a problem? The problem is that if you found the antiderivative of the derivative, so if I went, let's antiderive this function, and if you antiderive this function, the question is, which one is the real function then? Because if you're going backwards, remember the antiderivative of the derivative should give you f of x. So is the answer 2x plus 1? Or is the answer negative of 2x minus 1? It's kind of like your square root. You know, if you square root 9, is the answer 3 or is it negative 3? It's the same idea. Yeah? And because of that, we say now when you antiderive a function that has ax plus 1 on the bottom, and it's the power of negative 1, we say that it's log, and we do mod. Mod represents, so when you say mod of ax plus b, what this means is you got two scenarios. Log of ax plus b means that you can have log of the positive version, so this is the positive version, or you can have the negative version, negative of ax plus b. Okay? And that's what they mean. So that's why in your rule here, that's why part 4b is probably the trickiest when you first see it. Your textbooks would use a vertical line instead. They'd say modulus of ax plus b or absolute value of ax plus b. And what they're trying to say there is that there's two versions. There are two versions. You can get a positive ax plus b or you can get the negative version when you antiderive that. Okay, so I'm just explaining 4b so you understand that bit. If you rearrange this, that's how they get the conditions. Okay, so if you remember log, you can't log a negative number. So that means ax plus b has to be greater than 0. And then same thing if you did it this way, you get ax plus b is less than 0. So you get 2. That's why it's called a modulus or absolute value. Why is this key? It's the next bit. Here's an example. I'm going to delete the answers for it so you don't. You can see why they did this bit. Let's do this one together so you get a feel of it. Okay, so this is an example of 4b, an example of the rule for 4b. Let's have a look at this. If I asked you to antiderive this question, antiderive negative 2 over 3x minus 4. Don't forget the delta x. If you don't put the delta x, they'll penalize you. What we can do is we can take out the constant, okay, because it's timesing by negative 2. So let's take out the negative 2 to the front. And you got 1 over 3x minus 4 delta x. Okay, so I just took out the negative 2. Then from here, let's look at the rule. The rule tells you, if you're antideriving this, and notice it's 1 over ax plus b, my a is 3, and my b is negative 4. So according to the rule, I can write this answer as negative 2. I'm just going to leave it on the outside. The rule is you're going to have whatever a is, it's 1 on a. So I got 1 on a. So 1 on 3. So here's my a, and here's my b. Log, or ln, because it's log-based natural. Now, instead of writing two versions, you can write it with a vertical line and say, I've got a positive and negative version of it. And it is 3x minus 4 mod plus c. Okay? You see that? So instead of writing these two, I've just combined it in one shot. All right, so copy that down. Technically, this would be my answer. But they gave us this, where x is less than 4 on 3. This is where students can get this wrong. See, when you say x is less than 4 on 3, look at the condition here. This means if you times 3 to both sides, you get 3x is less than 4. But if you move the 4 across, it's when 3x minus 4 is less than 0. What does this mean? See, 3x minus 4 is in your log component. But remember the modulus. When you write the modulus sign, it means there's two conditions here. You can get either, number 1, it could be log e of 3x minus 4, where 3x minus 4 is a positive version. So if it's positive, you would say 3x minus 4 is greater than 0 because it's positive. Or number 2, it could be log e of the negative of this. Now the negative of this means times this by a negative and times that by a negative, so you end up with 4 minus 3x. But if it's going to be a negative version of it, that means 3x minus 4 is less than 0. So when they gave you that condition, what are they trying to say? You can't leave your answer here. You can't say, oh yeah, it's negative 2/3 log e of mod 3x minus 4 because you're saying there's 2 possibilities. But they clearly told you it's not 2 possibilities, it's only one of them. Out of these 2, this is the one that they wanted. So the answer had to be this component. Does that make sense? So that's the only part you got to be careful of. When you do the mod, there's 2 versions of it. There's a positive of whatever the brackets are, or it's the negative version of whatever the brackets are. And that's what that little condition is trying to say to me. So therefore, my final answer, if you put it all together, it should be negative 2 over 3 log e, and now it's not modulus anymore because I now know based on the condition, it has to be 4 minus 3x plus c. That's my correct answer. That's my final answer. But that's a typical one in an exam where they will try to catch you. So they'll know that it's, yes, it's mod. Most students now know to put the mod. Then they put a condition to see if you understand what that condition means. So that condition just means 3x minus 4 could be the positive or it could be the negative of that because the derivative of it is still the same. So you just got to look at the 2 versions and look at the conditions for it, which one fits. Okay? All right, team. That was example 1. And the rest now you can, I think that was the hardest bit to get your head around. The rest is just following the rules, 2a, 2b. 4a is just a simple reverse of what you do for log. So the derivative of log is 1 on x, so then the antiderivative of 1 on x gives you the log. Okay, and again, you get the plus or minus inside the log as well. So that's the only one that I felt that needed explanation, but the rest is just following the rules. I already got the solutions on OneNote for you to practice and check if you want to fill in the notes, especially in the back of the page, finding the antiderivative of these versions. So how do you rearrange them to solve? That's pretty much what exercise 11b, 11c. So for most best students, this is pretty straightforward. For the main method students, I do think you need to practice this from the exercise. Get a bit more familiar with different problems. And the last one is then to work, well, you have the plus c, and to derive the derivative, you get a plus c. So how do you find plus c? They have to give you an x and a y coordinate to then solve. Okay, so that kind of problem is in 11c. We're towards the end where you're actually now solving for the actual function. So start off by doing 11b, learn how to antiderive first, refresh your skills on how to antiderive. There's only that page that I've got up here that you can refer back to. Okay, so you just got to refer back to which one am I using, keep practicing so you know how to use them fluently. Then applying to solve to find C is the next bit in 11C. Okay? But there you go. I'm going to stop the video there just to finish off there. But I thought this one needed clarification mainly for the method students only. Most best would have seen absolute value. So you should probably understand that already. But if you didn't, hopefully that clarified why we have an absolute value for log. All right, team, I'm going to stop the video. And then you have about 35 minutes of